All right, so here we go. Guidelines for verifying fundamental identities. Number 1, work with one side of the equation at the time. It is often better to work with the more complicated side first. 2, look for opportunities to factor an expression, add fractions. The one we haven't looked at yet is square a binomial. We'll get to that one eventually. Or create a monomial denominator. That means one term in the denominator. Number 3, look for opportunities to use the fundamental identities. Note which functions are in the final expression you want. So that's that peeking over the brick wall to look at it. Sines and cosines pair up well, as do secants and tangents, and cosecants with cotangents. If the preceding guidelines do not help, try converting all terms to sines and cosines. Always try something. Even paths that lead to dead ends give you insights. I mean, that's telling you what not to do. All right, so in example 1, I want you to try this one first before I do it. And I want you to work with the left side. The left side's a little bit more complicated. And what I would recommend, like as you're doing your homework or you're working on the worksheet, write down the 3 Pythagorean identities, and then you can, use those and see those. All right, something I'm going to ask you to do now that these are freehand, they're not in a chart like we had on the other handout. Did you guys have any trouble finishing those yesterday? Remember we'd gotten to like number 5 or 6? You guys yesterday were supposed to finish those? You finished them? Mm-hmm. You did okay? All right. All right, so notice what I did. I used the Pythagorean identity that secant squared theta minus 1 is tangent squared theta. This is not the only way to do it. And then I put them in terms of sines and cosines. I had one fraction over one fraction, so I multiplied by the reciprocal. So when you're doing this, if you're going to work one side, because today I'm going to show you how you can work both sides independently, is you go down, but then when you get to your very, very last step, what I want you to do for me now is I want you to then bring the other side down and put a box around it. That's telling me you really know that you're done, okay? So you guys see that? That's what I want you to do. Yeah.
So on the worksheet, are we allowed to work both sides?
Yes.
Okay.
You just cannot do something to the left and the right side. Like you can't multiply, you can't add. But you can work the left side a little, the right side a little, and say, hey, they're the same. I'm going to show you that today. All right, example 2 says verify 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha equals 2 secant squared alpha. I heard a comment earlier about like alphas and betas and all the different Greek letters. If the Greek letters bother you, you may put X in, okay, and just put X. The problem is, as we move through this chapter, we're going to learn about sum and difference formulas and things like that, where there's going to be alpha plus beta. You can't make them both X's. You'd have to make one X and one Y. And so I don't mind, but just be consistent through the whole thing. All right, so I'm going to work the left side, and I'm going to build a common denominator. So I'm going to multiply, and I'm going to use alpha because I like my Greek letters. And so all I've done is I'm building my common denominator, okay? So this is 1 plus sine alpha plus 1 minus sine alpha over 1 minus, oops, why did I do that? This one's a plus, there we go. I was like, wait, that's not working. 1 minus sine squared alpha. I also want to mention something. Because I've taught pre-calculus for more than 20 years, I know what students do, or try to do, and I get something called, what I like to call the fudge factor. I'll have students who will get so far, and they're like, they don't know how to get to the rest of it, and then they have like 3 more steps to go, and they just write the right side down. If you do that, and it's not sufficient to know how you get from that step to the next one, I will take points off on a quiz, okay? So do not do that where you're fudging to say, all right, I don't know how to do it, but I'll just put that right side down.
You get partial credit.
You'll get some credit up to that point, but yeah. So the point that I'm trying to make is, first of all, don't do it, and second, try, like, do you see that, okay, those cancel, that's fine. 2, so from here, don't jump to 2 secant squared alpha, because I won't know that you knew that 1 over cosine squared was secant squared, okay? Or that from here, like if you jump here to there, I don't know that you knew that was cosine squared. You could have just been, I'm stuck and I'm just going to write the right side down. So then from here, it's fine to do that. Does that make sense what I'm saying? Don't skip too much, okay? From here to there, you would have lost points to have jumped from there. All right, now I want you to try example 3, and I'm going to share something with you. It's a little bit embarrassing as your math teacher, but I have sometimes done things the long way, and then I'll have a student who will raise their hand and say, could you have done it this other way? And it took them 2 lines, and I'm like, yeah, you could have. So on my paper, I did this a very long way, and then I have a post-it note that a student said, why don't we do it this way? And I did, and I was like, oh yeah, that was 2 lines. So I do that, then I write down what you guys do sometimes. That's when I don't see it, my blinders are on. So go ahead and try example 3. I'd recommend working the left side. The right side's just a little bit too simple. Right, if you're foiling, you're doing this the long way, okay? If you did foil, and that's honestly, that's on my paper, that's how I did it. So then here's what a student showed me. They said, well, tangent squared x plus 1 is secant squared x, right? Now, cosine squared x minus 1 is not sine squared, because we know sine squared x plus cosine squared x is 1. So if I were to subtract the 1, I'd have to subtract the sine squared, okay? So that's actually negative sine squared x. So be careful. 1 minus cosine squared is not the same thing as cosine squared minus 1. However, if I go this route, now that is negative tangent squared. Do you see how fast that one is?
That hurts.
Yeah. Oh, you don't have to tell me. I did it that way. And I was the teacher. So, Now it is possible, like I got it to work by doing FOIL, but it took, like a lot more steps to get there. So kind of my point here is, yes, when you see these products, most of the time you FOIL, but it doesn't mean you always FOIL. All right? So that's sort of the objective there. All right, example 4. Let's try this one. You try it first, and I want you to work the left side. Okay, work the left side. And I do have to tell you on the homework, the worksheet, I had some students come to me saying they were really, really struggling with it. And I pulled mine out, and on the back, I even wrote a note that said, on 11, I think I redid that one 3 times, and I whited it out. 9, 10, 11, I had circles and stars, and I wrote a note. If at first you don't succeed, try again. Yeah.
I can't do 10. I figured that one.
Yeah, 10 has a nice little twist to it. So we'll definitely talk about it tomorrow.
I had Lauren help me do this. Do that.
Somehow I missed something.
Lauren, I will
Plus
like.
cosine theta.
Oh, is she good at that still? That's great.
If that's cheating,
No, that's not. You can get her to, as long as you're understanding then after she's helping you. And I bet you a calculus student is like, can I go back there? I'd like to go back.
She offered to trade homework.
Yeah, I'm sure she did. Alright, with the left side, I rewrote it in terms of sine and cosine, right here. Then I got a common denominator. Then I noticed sine squared x plus cosine squared x is 1. Now, if you had sine x times cosine x in your next line, you want to flip it because I need the secant first, right? So you're just going to use your commutative property of multiplication, and there I have it. Any questions on that one? Alright, it says, recall from algebra that rationalizing the denominator using conjugates is a powerful simplification technique. We can apply it to trigonometric expressions, which we already saw this. So, on the right side, I'm going to multiply by the conjugate of the denominator, and you are allowed to multiply by the conjugate of the numerator when you need to. Now leave your numerator factored because it's our hope that something will cancel with the denominator. So this becomes cosine y times 1 plus sine y over cosine squared y. Now, one of the cosines will cancel. And you do want to peek over the brick wall, and you're like, okay, I want to get secant y plus tangent y. How can I do that? If you have a single term in the denominator, you may break it apart, but that's not true if there's a sum or difference in the denominator. You can't do that. So that's secant y plus tangent y. Yes.
Am I allowed to break the one on the bottom into 1 plus sine y times 1 minus sine y and then cancel the plus sine y?
Okay, say it where?
Like, right, you switched the 1 minus sine squared y into cosine squared y.
Yes.
But couldn't you just factor that and then cancel the 1 plus sine y?
But then
also?
you're stuck. You're back here then.
Oh, okay.
Yeah.
I don't.
You can,
Yeah,
but then
okay.
you're right here,
Alright.
and then you can't.
Alright.
Then you gotta do it again and hopefully move forward from there. Okay? Alright. So, examples 1 through 5 we did by working one side and converting it to look like the other sides. Now we're going to look at an example where we're going to work both of them, okay? But keep in mind you cannot do things to both sides of the equation. So watch what I'm going to do here on the left. And as I'm looking at it, I'm like, oh, I probably should have done it this other way, but that's okay. I rewrote cotangent squared as cosine squared theta over sine squared theta. Now, you guys, that is not the only way to do the problem. I could have, if I looked at that denominator, I'll bet you 1 minus cosecant squared theta is equal to cotangent squared theta. You could have used that Pythagorean identity. And on the right side, I'm going to multiply by the conjugate of the numerator. So remember, this equal sign is not like an equation. This is saying we want to verify it's an identity, so I don't know that the equality is true. That's why you're not allowed to do things to both sides, because that's assuming it was already true, which we don't know, okay? So I'm just working the left side, what I know, and I'm working the right side. And the goal here is to get to some place where the two sides are the same, okay? So here, I'm going to, and if it bothers you to be doing both of them, I mean, then that defeats the purpose of working both sides. Like, if that's too confusing, you could do one until you get to a certain point and then work the other side a little bit. Oops, I was talking. I was talking and got distracted there, sorry. Let me try this again. So this is cosine squared theta over sine squared theta. I'm not doing anything to that. But then I'm going to build a common denominator here, and that's sine theta plus 1 over sine theta. Over here, what can I do? That's 1 minus sine squared theta over sine theta times 1 plus sine theta. And then some of this is starting to come to light now. There, I can sort of see what I can do here. I'm going to multiply by the reciprocal here. And do you see one of the signs will cancel? And I get cosine squared theta over sine theta times sine theta plus 1. And like, they don't have to have the same number of rows. Like, I can get to this up here and stop and, you know, go down 2 more lines as long as the two are eventually equal. Because then, do you see here, that's cosine squared theta over my sine theta. Then I'm going to use the commutative property again. So that's a very, very important property. Now, do you see they're equal? I will go ahead, though, and just bring it here so that I can box it. So, you can work one side to look like the other side. You may also work both sides until they look the same. Either is okay. Either is okay. All right, any questions on these first 6? All right, because we're going to talk, when I'm done with this, we'll talk about, I'm seeing some common errors happening in terms of what we're trying to do. And I need to remind you that if you're trying to, and you don't know that you've seen us quite do it, but you're trying this new technique of trying to cancel something, put numbers in the place of every, like, sine x, put a number like 4, and see if it works with the numbers. If it does, then you can do that. But if it doesn't work with the numbers, it can't work with trig expressions, okay? Trig expressions are really a placeholder for a number. That's it. Just much more complicated than what we've done. All right, try letter A here on example 7. I'll give you a head start. Obviously, the right side looks more complicated, so let's start there. that one was nice, wasn't it? Yay, we can do that.
Dang it.
What? What'd you do?
Nothing.
Sorry. Don't you see the GCF? There's a tangent squared x. And then secant squared x minus 1 is tangent squared x. Were you doing sines and
Can you do that
cosines?
in a different way?
Yeah,
Can
absolutely.
you show me a different way?
Sure. Let's do it Adam's way.
It's not.
Did you do sine squared over cosine squared?
Yeah.
Okay, let's try it. Let's see what happens. All right, let's see. Well, they don't have a common denominator. So do you see I would need to multiply this one by cosine squared? So that would be minus sine squared x cosine squared x over cosine to the 4th x. Now, I mean, you're still at some point you've got to catch the GCF. Ah, there we go. Now that's sine squared, right?
So at this point, you
So
can just
s-
work the other side instead.
Alright, so that's your sine to the 4th x over sine to the 4th x, or cosine to the 4th x, which is tangent to the 4th x. A lot more work.
Exactly. I was like halfway through and you guys are already
Are done, yeah.
done, so.
Okay, then let me help you in letter B before I have you go down a rabbit trail. And letter B, on the right side, do you see that there's a cosine to the 4th x in common? And if you didn't see it, now you see it. Well, 1 minus cosine squared x is sine squared x. So that's sine cubed x cosine to the 4th x. Alright, now that I've done letter B, use that same technique with letter C. Okay, you guys got it?